So for project 4, we're going to do some deep learning with neural networks, and we're going to revisit, I mean, not revisit, but visit, and look at a Kaggle challenge. This is called the PetFinder challenge, and then again, Kaggle is this website where they post a number of data challenges. So this is one of the newest ones. There's actually a little prize money associated with this one. But there are only 18 days left as of this recording, which is so I think it goes about to the end of the month, it looks like. But so quick overview of this. This is looking at a bunch of information from PetFinder about pets in Malaysia. And what we want to do is predict how quickly the pets will get adopted so that in the future they can try to work on ways to help pets get adopted even faster for this. So there's a little description here, and then there's a bunch of data given for each pet here. And so I've created an initial project for you here with this. As before, we import the libraries we're going to need, and then here's an overview of the data that we have. So here's the main information about the pets. We also have things like semantic information, descriptions of the text that was used to describe the pet, and images. In the future, probably in a couple weeks, we may revisit this and do some more image processing when we get to our image processing CNNs and working with those. So we'll be using convolutional neural networks later on. One of the things is that we'll be looking at this data and coming back and talking about it and how we might use this. So this is an overview of it. So the data I've downloaded from PetFinder here and posted it to GitHub so you can open it up and read it in. There's a set of training data with pets, and then a set of data you have to use for submission. And this is not labeled. The submission data is unlabeled, but the training data is labeled. And then there's a sample submission, and there's also some information about the colors and the list of colors and breeds and that sort of stuff that's read in, but right now we're not using that too much. Okay, so there are almost 15,000 pets in the database for training, and then about 4,000, just under 4,000 pets that you have to calculate. You know, there are 24 fields in the initial training data and only 23, and that's because, again, we are needing to predict one. So let's just look at the data real quick here. This is our data that we have. And if I scroll over this, one of the things we have to do is predict the adoption speed here and how quickly the pets are getting adopted. And so if I scroll back up there, the adoption speed is 0 if the pet was adopted the same day, 1 if it was the first week, 2 if it was the first month, 3 if it were in the second or third month, and then 4 if it was more than 100 days for that. So that's in our database here, and again, that's what we need to predict. So we're going to be looking at a pet and try to figure out, based on its information like its breed or color or maturity or health, things like that, if we can predict when it's going to be adopted. Again, there's also some text information here about it, but right now we're not going to do what is called semantic analysis, where we try to analyze this text. Although you're welcome to try anything you want right now, but that's not we're not going to be necessarily covering that in this lecture. So the first thing we want you to do is select some features. Here I'm just selecting 4 general features: the age, the gender, the health, and the maturity size of the dog. So I'm selecting those features from the training set and staving them into something called pet train. That's a data frame here. Now, if we're selecting these features, we want to do the same thing to the submission data, because we're going to want to process the submission data in the same way. So I'm going to select the same features out of the submission data and call that pet submit here. Again, so I've got 5 data elements here in my training data. And then again, for my pet adoption stuff, or what I'm predicting is, again, 5 elements. One thing we are going to do is we're going to just categorize this input here. So if we look up at this adoption speed, rather than, it's hard for neural networks to predict a number like 1, 2, 3, 4, 5. It's easy if we switch that to one hot encoding. So we'll have one output node that'll be represented of the 0 to, or the same day, another node that will be representing 1 to 7 days, and another node for the first month, and that sort of stuff. So we'll have different nodes in the output for each one of these. So this is called the one hot encoding, and only one of them will be active at this time. And so we'll make sure we set up our data to do that one hot encoding here. So if we look down here, we're going to talk about modifying some of these features. I'm going to just skip over that for now and come back here and here. Now, here we're going we're going to scale the data and split the data up. So we're going to load in a scaler and scale the data. And again, we're going to scale the submission data with the same scaler as the training data, so that it's trained, so that we can run the submission data in through the same network as the training data was run. And so here's what it kind of looks like after it's been scaled. All the values are between like small, about maybe negative 2 or 3 up to positive 2 or 3. So we don't have any really large numbers or any here. And then we're breaking the data into train and test data. So we're having a train test split. Right now I've got 10% here, but you could change that. And again, we're using the pet trained scaled and the adoption speed information up here that we have set up. And that's saving this as the X train and Y X test. And so now we have training and testing data. And so we've got about 13,500 pets in the training data and about 1,500 in the testing data. And now we'll define a neural network. This is just a simple one. And again, this is where you'll spend some time trying to improve this. But this has a dense layer of 20 that'll take the input. We then are doing a dropout at 0.3, another dense layer of 10, and then an output here. And then we're calculating the input and output size here based on the actual data that you have. So if you add or remove features, it'll automatically change this network to the right size for you. So you can add layers in here if you want, change the size of these layers, do whatever you want to this. Remember last time we talked about callbacks in the last practice activity. So there's this learning rate reduction. Right now we're returning the learning rate by 1/3. If on a plateau when it doesn't learn, we also have early stopping set up. So if it doesn't change after I think 6 epochs, it will stop here. And again, you could save the output of this if you want, although I'm not using that right now. And now here we're actually calling fit, so we're training on neural networks. Oh, I just noticed I'm using I'm still using that name, digit neural networks, throughout this. And we're doing pets, but I should probably just go through and change all of the digit neural networks to pet neural networks. In a lot of my systems, I just call the neural networks NN for neural network and don't differentiate it, but so that would be another option here. But okay, it's fortunately still called the digit neural network. We're going to train it for 10 epochs. Again, that's just a sample here. You probably want to do at least 100. You'll have to watch the learning rate here. But I just ran it through a couple as we go. And then I can print out the test data, and right now I'm only getting 36% correct. And I can look at this learning rate And I don't know why the value is why the loss isn't showing up here right now. Now this is a challenging data set. This is a very hard problem, so you will not be able to get very good results here. You certainly won't be able to get up to like 90, 95%. You'll struggle here, and in fact, even if I run this for 100 times right now with the data I have sucked, I won't get very high. It will just bounce back and forth around 36%. If I look here at the top results here, the leaderboards, the best, the top results currently are under 50% here, and there are lots of people down in the 20 and 19%. In fact, even though you're predicting here at 36% with this sample data, when you actually run it on the submission data, you'll get much often poorer results depending on how you have that set up. Okay, so your job is to try this out, get the data, try out different information, try to improve that. And then you'll create a Kaggle submission here. I'm just going to show you quickly how you do this. Before we've submitted a data file, created a data file as output and just been able to submit that data file to Kaggle. But we find some people often cheat with that. There's ways around that and things like that. And so on a number of Kaggle submissions now, they want you to actually upload your notebook and do that. So what I would do here is I would save this notebook, download this notebook on my computer here. And then I go to Kaggle here, and again at the top, one of your first tasks is to sign up for this Kaggle challenge. So you'll sign up for that, and then you'll be able to submit a prediction here. And they show you some pictures here. What you have to do is you have to upload a kernel and run that kernel here. So you can click this new kernel here. There's this little kernel tab up here that goes to the same area, and you can see your work. I've uploaded one kernel so far, and I can upload another one here. So I'm going to do that here. Okay, so I'm going to go new kernel here. And you can either write a full Python script or a notebook. And again, we've been using these Jupyter notebooks, so that's what we're going to do for that. It will create a blank notebook for us, for you to work with. And you can actually put your code up here. What you're going to want to do is upload your file at this point. This is just a sample file here. So I'm going to upload my file, go out there to downloads and find the file. Upload that again. And it's here. And now I can actually run this in place. They have a pretty fast processor, so I can just like I'm running a Jupyter notebook here, I can go, and in fact you can do your whole development here if you wanted. And then download it back later on. So I can go through here and run this notebook. Now one problem I wanted to point out is that you can't grab data from GitHub in Kaggle. You have to use their special input files and stuff like that. You have to use their files here. So here I have a link for both a GitHub folder and a Kaggle folder, and I have that defined. And then I say the data folder, and right now it says the GitHub folder. Now I'm on Kaggle. I have to change this to Kaggle folder. They'll have their own data environment over here all set up, and so I can just change this one thing where it says data folder. Actually, now to read my instructions, it says to just comment this out and uncomment this one. Yes, so now that'll be the Kaggle data, and it'll read up the data there, and it should be basically the same data that we had before. So you just have to do that. When you see that error, you'll remind yourself of that. Okay, I noticed I'd accidentally deleted this line that converts the output stuff to a categorical, the adoption speed stuff. So there was an error. I fixed it in the main stuff. So if you get this error where it says the pet adoption speed is not defined here, make sure you put in this line here. Okay, so again in Kaggle we can just go through and work on this. We have to train our database here. So we'll just do that, and that's why initially I have this relatively slow stuff. But again, this runs on a pretty fast processor here, so it will go through our training relatively quickly. We can talk later about how you can save your weights and upload those weights here too, I think. But for what we're doing, you should be able to just display the information. Now here we're generating our predictions. So we generate the submission called submission.csv. And so once we've done that, and it just shows this, we're ready to submit that to Kaggle. And so we can just go to, I forgot one thing we have to do is we have to commit this. That just saves a copy of it. So you have to give it a title here. So I'm going to call this project for second try. And save it as a Python notebook here. And then once you get the name set up, this commit one will change to blue, and you can commit this, and it just takes a while to save this and record this. And then again, as you make changes, you can recommit this, and it'll save your changes as you go here. So I'm gonna so it should execute the whole notebook. So now it's running the code. And so again, the first, when I'm doing this, I'm going to just let it run and just wait. And then it should have the complete version done here. So, and then I can just return the editor, and then this should be committed. Let's see, why didn't that work? Okay, now to do the submission, you've got to go back. We're in the edit mode here, and we committed it. When we committed it, it runs it and saves the output file. Now I hit back. That'll get me out of the editor here. Oops, let me reload this. It should have gotten me back to out of editor, but I was trying out some other stuff to figure this out and goofed up that link back because I opened up another window. Okay, so now I'm in my kernels here, and I was in the second try kernel. I'd gone and edited it here, and then I hit the little arrow here to get back to this location. Now I have to go to the output. It should have generated some output here. Here's my output, and I want to submit this to the competition. So again, make sure you click on the output here at this point, and then you can submit it to the competition. It will submit it, and it'll show you where you are with the results. Should run this, and again, right now this is not getting very good results. Again, even though it seems like it is with the testing data, when we run it with the actual submission data, which is more complicated, it gives me a lower score, much lower score here. So your job is to improve this score. You can, right now it's again only getting 17% on the submission stuff, and to try out different things. Okay, I'm going to record a separate video with some hints on how to record, how to do some improvements on this.